now. And as last time, the recording will be available on the web page. So we tried to navigate clear of any conflicts, in particular with Ayala. On some magic way, we managed not to do that. So there's an Ayala workshop going on right now in Edinburgh. So unfortunately, our first speaker will be Minsu, but it will be a recording. But we will go ahead with his introductory presentation now.
Good morning, good afternoon, everyone. It is my great pleasure to present at this important seminar today. The title of my presentation is about MCP and SECOM work in international organizations. Well, before we dive into the technical details of the SECOM and MCP, I'd like to take a step back and share some broader perspectives on digitalization from Ayala's viewpoint. Today, the maritime digitalization is not merely about adapting new technologies. It is about building a global framework of the standardization and trust. I believe there are four major trends that are shaping the future of the maritime sector: automation, connectivity, sustainability, and digitalization. First thing is on the autonomous. Although the development of the MaaS is progressing more slowly than initially expected, the potential impact is significant. The autonomous technology could fundamentally reshape the maritime infrastructure and operations. That's why it is important to closely monitor its evolution and prepare for its eventual integration into the normal operations. By the way, the IMO MaaS voluntary code will be finalized in this year. Secondly, for the connectivity, although some questions remain, we already seen enhancements to the legacy systems, such as VDS and NAVDAT, that improve the existing service capabilities. On the VDS-related matters, the last IMO MSC approved the draft amendment to the SOLAS Chapter 5 and its appendix to introduce VDS, entering into force on the 1st of January 2028. And this will be adapted in MSC this year. Additionally, the rapid expansion of the low Earth orbit satellite technology is overcoming the long-standing cost and bandwidth limitations in satellite communications. As a result, connectivity is becoming more accessible and its application continue to expand. Ayala is hosting a workshop in Edinburgh this week to discuss how coastal states can establish future radio communications and navigation infrastructure. And thirdly, addressing the climate change and supporting the UN Sustainable Development Goals are now essential considerations in every areas of the technical development. Lastly, about digitalization. Well, in fact, digitalization in the maritime sector didn't start just recently. It can be traced back to the e-navigation initiative, which began more than 20 years ago. The fundamental goal of the e-navigation has always been the harmonization of how marine information is collected, integrated, exchanged, presented, and analyzed. Within this framework, services such as search and rescue, pollution monitoring, and communication have been developed. I will explain the maritime services and technical services and product specifications in more detail in the following slides. But let me make one point here about the communications. We are entering a new era where the multiple data exchange channels are being available. This includes IP-based communications such as LEO satellites, mobile, and also non-IP-based communications such as VDS, AIS, and ASM. Among these, VDS is expected to play a particularly important role in enabling maritime digital communications in the near future. Just recently, IALA approved two important developments. First one is about VDS authentication and also VDS signal measurements. These steps mark a significant progress in preparing for a more connected and data-driven maritime environment. To enable digitalization and e-navigation, there are three main building blocks are required. The first building block is a description of the maritime services in the context of e-navigation. These define the services at a higher level, including their operational aspects. In a simple term, maritime services need to be described in a harmonized way worldwide. On the right side of the diagram, the second series of building blocks is product specifications. Harmonize the data format standards based on the S100 framework. The final building block shown in the middle is about how we exchange the data and information. This is where the IALA Guideline 1128 comes in, providing the standards for information exchange that make seamless communication possible. Ship-to-ship, shore-to-shore, and ship-to-shore. These relationships are not strictly one-to-one. A single service can connect to several others. With this framework in mind, let me now walk you through each building blocks in more detail. On this slide, let me show you how these elements fit together within the overall IALA framework. It summarizes the key IALA publications that define the maritime services, technical services, and product specifications, all of which collectively support the S100-based digital ecosystem. At the top, we have a standards 1070, which provides the overarching framework for the information services. Beneath that, there are two recommendations, one covering the maritime service and another for product specifications. However, at this stage, there is no dedicated recommendations for the technical services. For maritime services, we have a guideline 1155 and 1161, which describe how to develop maritime service definitions and evaluation platforms. For the specifications, the committee revised guideline 1106 last year, providing updated procedures for producing IALA product specifications. And for the technical services, several key guidelines are in place. Firstly, guideline 1128 on specification of technical services, and 1157 on web-based S100 data exchange, and 1183 on the provision of the MCP identities, and 1191 on the maritime service registry. Together, these standards and guidelines support the ongoing developments, both product specifications and the technical service specifications. Finally, we also have two testbed platforms supporting this work. For the product specifications, the IALA S200 test and validation tool, and for the technical services, the Open Digital Incubator, which enables testing and validation of the new service specifications. I would like to give you a little bit more detail on IALA publications. One of them is G1183 on the provision of the MCP identities. This guideline defines how secure digital identities are issued and managed within the MCP. It establishes a foundation for trusted maritime communications by assigning each entity a unique maritime resource name and linking it to the certified digital identities through a decentralized public key infrastructure. This document ensures that ship services and authorities can authenticate and exchange information securely in a global maritime environment. Another document I like to introduce is 1191, which specifies the technical design of the Maritime Service Registry, which is another core component of the MCP. The MSR allows ships and shore systems to register and discover maritime digital services securely through a standardized interface and trusted identities. Together with the 1183, it forms the backbone of the globally connected and interoperable digital maritime ecosystem, supporting the transition to the next generation of e-navigation and S100 based services. On this slide, I'd like to introduce the maritime service making the use of digital route exchange in terms of the vessel traffic services. In the VTS committee is discussing the potential use of the digital route exchange. This is still a work in progress, but at the moment, 4 possible services have been defined. The first one is a VTS route exchange service. The base for all others. It allows vessels and VTS to share a planned route in a standardized format, creating a common understanding and reducing the VHF radio load. And secondly, on the route reference service, VTS offers a recommended route in electronic format to assist mariners during the planning stage. And thirdly, a route cross-check service. VTS validates a ship's planned route against the local expertise, tracking factors like underkill clearance and the air draft before the vessel enters a critical area. And lastly, a route monitoring service. During the voyage, the VTS monitors movements in the real time to detect deviations and intervene promptly if hazards arise. Where these technologies are not developed in a vacuum, practical testing and validation happen through a global community called the Open Digital Incubator. Coastal states including Finland, Canada, Australia, and South Korea, and many other nations are already implementing these services in their own waters. They are proving that G1183 and also G1191 can work together to ensure a ship receives an uninterrupted digital services as it moves from a global port to another. In conclusion, the evolution of the e-navigation, the trust framework of the MCP, and the advanced VTS services we discussed today all share a single goal. That is to enable a safer, more economic, and more sustainable maritime future. Technology will continue to advance, but the trust and standards must remain at its core. Thank you very much for your attention.
Thank you very much, Minsu. I will thank him in person when I see him. So this was, of course, not the intention to have this recording, but the rest of the presentations today will be live presentations. We will keep this a little bit more informal. Maybe you could see in the program we'd have not designated times for questions and answers. So if you have any questions, then please just raise your hand and we'll take them during the presentations. And now we will dive into the more technical parts of the stuff that Minsu talked about. So over to you, Raman.
Thank you. Let me just get the share going. And I will keep you in this format because if I'm on a big screen and if I start going to presentation format, it does not end well. Please feel free to interrupt at any point if you have any questions. And just to dig in, so this is the first of two sessions going into the CCOM standard and the CCOM interfaces. And I'll go through the architecture and the PKI at first. But first, we'll go a bit into what actually is CCOM. I know it's an acronym that everyone is probably familiar with to some extent, but it is specifically an IEC standard that defines secure communications between ship and shore. While it can be used between ship and ship or shore and shore, the main intention is specifically between ship and shore. And basically it consists of REST APIs, and on top of those defined REST APIs, there are definitions around authenticity, encryption, compression, and interactions between the different actors. One frequent comment that I hear, and one that I remember saying myself as well, is it is too complicated. It does look like that at first, but there is a reason for that. But the main thing to remember is that CCOM is only a building block to help the developers of digital services and the consumers of these services in the maritime sector. So CCOM in itself is not an end. It is only a building block and a way to avoid having to implement the same thing a million times. We'll get back to that soon. So the building block basically is that CCOM lays here in the communication layer, providing some tools for the communication of information. And of course, on top of that, we have a functional layer where we have that information being given some kind of function, for example, navigational warnings, route exchange, or something like that. And on top of that, we have the business processes. So even if you have CCOM implemented or some other communication protocols implemented, even if you understand the information, in many cases, that is not enough. You still need the functional and business layers still. So CCOM is a very small part of the services in the maritime sector. But it's a standard set of REST APIs that define interactions between services and the consumers. Simple enough there. Primarily, it is data agnostic. The CCOM APIs themselves use JSON as the data format. The payload is base64 encoded, so it can be anything. Primarily, of course, we're talking about S100 and S200 products, but it can be whatever you need it to be. All of the communication is secured with standard TLS security. all of the communication is signed. And this is now where we get into the more maritime specific issues. And then, of course, it supports payload encryption as well. And we'll go through all of this in more detail. So the building block. At least some of us here are probably old enough to remember the browser wars of early 2000, where websites were actually littered with these kind of icons where you had this page best viewed in this or that. And probably everyone remembers also various sites that only worked on Internet Explorer version something in corporate environments. The idea with CCOM is specifically to standardize the communication between the ship, the consumers, and the services. So when you implement, or specifically when we define a service specification and a service design, then we have this situation where everyone can implement consumers for these services, everyone can implement these services, and things should work. Of course, it means that we need to have agreed test methods, etc., to ensure that interoperability, but it is one of these building blocks that help everything. Also, because CCOM standardizes the way the signing and encryption and all of this works, it means that every single service does not have to reinvent the wheel of how it is done. And consumers don't need to re-implement different ways of handling certificates, encryption, signatures, and all of that, depending on the service. Just to ensure that we're talking about the same things, I'll just put a few definitions out here. So a service is a shoreside system providing a service for consumers. Route exchange is one example, which is, of course, very central at the moment in all of the discussions. And these are typically integrated with back-end systems. So it will probably be a part of, for example, of ETS system or something like that. Then the consumer, in this case, is a system using the service. Here I talk about ship systems. We can also just simplify it and say that a ship is the consumer and say that any shipborne equipment can be the consumer in a way using the service there. Then from a CCOM perspective, both the service and the consumer have to be able to work as a server and a client, specifically HTTP servers and HTTP clients. And then this used to be called the last mile. In the latest IEC Working Group 17 discussions, we are trying to get rid of the term last mile because everyone understands that in very different ways. And now we're just in the diagrams trying to convert it to vendor API, which is a communication link between the shore server of the consumer and the ship systems. There are existing implementations for this, and there's no need, currently at least, to say that you have to implement that functionality in a certain way. So CCOM's architecture looks like this. This is from the latest draft of the CCOM standard. And if we start from the service side, we have a maritime service provider who provides a maritime service, which communicates via CCOM information service interfaces with a shore CCOM interface, which is in a data center or a connectivity provider, however you want to term it, which then communicates using the vendor API, which we are not trying to standardize at the moment, either 4G, 5G, IP-based communication or non-IP-based communication. As long as you can get the data transferred, it doesn't matter how it happens. To the shipborne systems. The CCOM standard allows for different ways for this part to be implemented, but the standard describes specifically this approach, where we have a 460 gateway in which there's an application service, which is a CCOM terminal, which then handles the transformation of the communication from CCOM style communication to what the 460 gateway and the shipborne equipment understand. The ship is registered in one identity registry.
There's a squirrel on it the other day.
Sorry?
About.
Okay. And likewise, usually a maritime service is registered in a single identity registry. The identity registries and service registries are supporting the CCOM communication. You can implement CCOM without having an identity registry and a service registry as long as you have an X509 certificate. However, the maritime service or the consumer might not accept that kind of a certificate. So let's go to the part of CCOM is complicated, which it really isn't, but it can really look like that. One of the reasons why it is somewhat complicated is that it has to support communication via poor connectivity. So the server on land, the service itself, usually has pretty much all the time reliable connectivity. While a ship, as we know, might not have reliable connectivity. And for bidirectional communication, we need to ensure that the bidirectionality works. And that's why we have the shore CCOM interface, which ensures that the service can communicate with the shore CCOM interface and the ship can pull or whatever method is used here to get the data from here to here is possible. We're not defining that. And on the other hand, data compression is also defined in the API to ensure that we can handle more limited bandwidth situations. So for example, the latest version of the S421, so the route exchange format, is fairly verbose. And we've been testing it now with a route that has 4,900 waypoints. Uncompressed, even a simple route with 4,900 waypoints is over 1 megabyte of data. Whereas if you compress it, it drops to about 60 kilobytes, which means that we achieve significant savings in bandwidth and complexity through that. Then it also has to support the synchronous processes. We have to remember that pretty much all of the business processes in the maritime sector also involve a human actor, either a mariner on board the ship or, for example, a VTS operator on shore. And that means that there has to be asynchronous processes set up. And that's why we have a HTTP client and a server on both sides, because WebSockets will not work. Again, the reason for that is the previous slide and poor connectivity. So the used interfaces, and we'll be going through the interfaces in the next session. The used interfaces for this are upload link, get by link, access, and access notification. And that's also the reason why a simple synchronous get from the shore to ship is not ensured to work. And in fact, even though there is a get operation defined in CCOM, the latest draft of the standard highlights the fact that the get from shore to ship definitely is not ensured to work, because a get is a synchronous operation and you cannot ensure that you can do a synchronous operation from the shore to ship side. Also, one part of the complexity, especially around the communication or talking about CCOM, is the acknowledgements, which exist there so that it supports closed-loop communication. For those of us from a more technical background and not a maritime or radio usage background, closed-loop communication means that you repeat back what you heard in the transmission to ensure that the key points of the transmission were actually received correctly. This is, of course, really important when you're transmitting numbers or dates or times or something like this. But basically, all radio communication is based on closed-loop communication. To ensure that in this kind of digital realm, we have in CCOM acknowledgements, which differ from the technical acknowledgement at the end of a HTTP TCP connection. These acknowledgements are specifically there to show that something was delivered to an end system, to the actual consumer, and possibly that it was opened on an actual consumer. The definition of what means when it's opened is up to interpretation. For example, in the latest drafts of the ECDIS testing standard, it is specifically that a mariner interacts with the route in some way. So usually it is defined that a human has to actually interact with it. And this is the acknowledgement interface that will handle this part. Then we have the support for payload encryption. And this is simply because there's intermediate steps that may not be trusted. You can have actually mission critical data being transferred without the CCOM shore or the shore CCOM interface being able to access the payload itself. And thus the interfaces exist to exchange one-time secrets. This is pretty standard from an encryption standpoint, not complicated in any way, but it does add a level of complexity again to the APIs provided. Then, of course, there's the fact that because we don't know how large the payloads necessarily are and how large a payload a server accepts, there is a need for a fallback system. So because HTTP has no standard maximum size for post methods, the thing is that we have to have a way of sending the data even if the initial post fails. So again, if we have a post that the server doesn't accept with an error 413, which basically means that it's too large, then what you do is you put the payload available somewhere. You post a link to that payload, and then the server can do a GET. So basically this means that the payload needs to be transferred if we're saying that the ship is now trying to send a route that is too large. The ship will deliver it to the shore CCOM interface, get back, and once it knows that the shore CCOM interface has it available, it will post then to the server that here's the link where you can get it. And then the server will do a GET to get that link from the shore CCOM interface. And then there is support for requesting access asynchronously. Basically, this means that you could have a shore service which wants access to a resource on the ship. And it can request access for it, and a mariner could receive a prompt saying that, okay, this service wants to get the latest version of the monitored route or something like that. And then the mariner can decide yes or no, do I accept this? And then through that, then there is a method of ensuring that the route is then shared. The actual use cases for this need may be rare, but the standard does support it. And then we go to the public key infrastructure that is defined for CCOM. We're talking about standard X509 certificates. The IALA specification G1183 that Minsu talked about previously defines additional field to adopt the approach better to the maritime domain. This means that, for example, there we have a mapping between the MRN of a vessel and the IMO number of the ship. So that way, for example, you can connect the certificate to the AIS data that you're receiving and have those in line that we're talking about the same ship, for example. CCOM version 1 supported MTLS to get the certificates and signatures and all of these from end to end. But in testing implementations and actually starting to implement, we noticed that MTLS becomes very complex to implement, especially with different kinds of architectures. And thus, in CCOM version 2, we are now dropping support for MTLS, and the certificates are being delivered as a part of the CCOM headers or the CCOM envelope in all of the requests. And then what is important is that the CCOM envelope, so basically the transport layer and the payload itself, may have different signing entities. So if we look at this diagram now, below this main arrow that is going through the diagram, we have standard internet security, where basically this communication pipeline of HTTP and TLS is protected by normal TLS certificates given out by trusted internet certificate authorities. This is just standard stuff that the internet uses. PKI for CCOM is here on the top layer, where first you may have the payload being signed, but with a signature, which is then at the CCOM information service interface then enriched with an envelope signature. So basically this post that is being sent, for example, or a GET is then signed with the whole envelope. And of course, the certificate is being passed through it. And then when at the other end, a CCOM information service interface receives the data, it can do envelope signature verification. Of course, this one has its own certificate. Here we may have a single certificate handling both of these, or we can have two different certificates. One reason why the payload can be signed with a different certificate than the envelope is that you can have a payload that is generated and signed with an IHO-based certificate, while the envelope, the actual service, does not need to have an IHO signed certificate then. I'm trying to keep an eye on if there's any hands raising, but if I don't notice, you just open your microphone and raise your voice. So what's missing? Well, if you've looked at the published version of CCOM, you definitely notice that it refers to outdated algorithms. So revision 2 will update all of the algorithms to modern versions, and specifically it will allow for updating the algorithms as recommendations change without needing to update the CCOM standard itself. Also, what revision 2 is, it removes dependencies on the consumers being registered in service registries. So previously, in CCOM version 1, the only way that a service could find the endpoint of a consumer was by the consumer also having to be registered in a service registry. And this is a bit of a cybersecurity issue, or it opens up the or the shore CCOM interfaces more for cyber attacks. And it also opens up some other issues, but we can talk about those a bit later in the session. What CCOM does not define is how many times you have to retry if a call fails, or with what kind of cycle this has to be done, or whatever. This is left more to the service designs on how it has to be handled. And CCOM also does not define a business processes around a service. So again, we're just talking about defining APIs, how it works in a service. That is then left up to the service specifications and service designs that do this, especially if they're specified according to IALA's guideline 1128. So we still have about 10 minutes left, so we have a lot of time, but on the other hand, that's not a problem. So what it looks like for the future at the moment, revision 2 is under work by the IEC Technical Committee 80 Working Group 17. I would strongly recommend that any implementation work is done against revision 2. It has been a moving target for the last year and a half, but now the actual interfaces are already fairly tied down. So we are currently writing or finalizing the version that will go for committee comments. So the next CD version should go out at the end of February. And then specifically the timeline is that these CD comments will be resolved in a meeting in May. And the timeline is to get the voting version of revision 2 out by the end of the first half of 2026. So basically in June. And then it will go out for voting and hopefully pass as it is. The timeline is currently extremely tight because then, for example, the ECDIS testing standard depends on the CCOM standard, as well as, of course, the S421 standard as well. And that has to go into CDV in the third quarter of this year so that it can be published as an international standard in time for type approval agencies to be able to type approve the S100 ECDISs in time for 2029. So we are at a very critical timeline phase, but at least based on the latest Working Group 17 meeting, it looks like from the CCOM perspective, we should be at a fairly good situation. Any questions? If not, this presentation will also be available at the website, and at the end, I also have a link to IALA's site where you can find all of these mentioned guidelines as well as the service specifications for route and design for route exchange, for example. And test data for CCOM, the older version test data is available at the CIRM website. It is still under discussion, will the next version test data be available there or somewhere else? But those will, of course, be updated as they're figured out. And I have to note also that there actually is no test data available for version 2 yet.
All right. Thank you very much, Ramin. And yes, I mentioned in the beginning that it was a pity that we had a recording for the first presentation, but now there's no questions at all. We might have just recorded the whole thing and then just show you CCOM and MCP, the movie, coming to a theater near you. So if anybody have any questions or anything, please raise your digital hand, and if the presenter doesn't notice, I will notice. So yes, please, if you have any questions. But thank you very much, Ramin, and we will move on in the program. And I see that Lawrence is emerging here. So we'll continue with the second presentations, and over to you, Lawrence.
Thank you, Thomas. So I'll just share my screen. Okay, so we're going to carry on talking about the SECOM, but we're going to be looking more at the interfaces. So in this presentation, we're going to look at the SECOM context, but a lot of that was covered by Ramin's presentation very well. So then we have some of the SECOM interfaces. We'll look slightly more into the ones that are used for SECOM services. We'll give a highlight on some of the important data structures. Then look at the SECOM library that we in Grad produced and the XML binding repo. So, similar to what Ramin said, the SECOM specifies a set of APIs for data exchange from ship to shore, shore to shore, ship to ship. It also defines the data protection measures, the digital signatures, and the interfaces for service discoverability. It defines the data structures. It's designed to work with S100 data products, but again, as Ramin said, it can be base 64 encoded payload, so we'll support pretty much everything. Okay. This is a very similar diagram to what we saw in the last presentation. You have the data providers here, the ship services on this side, and then SECOM sitting in the middle, moving the data from one side to the other. And it also defines the service discovery and the security. So the SECOM APIs are split into three sections. There is the bulk of the endpoints are in SECOM service operations. We have get summary, get subscription, and then a few endpoints for large data transfers. We'll be focusing mostly on these ones in this presentation, but there are also PKI service operations, checking the status of a certificate with CRL or OCSP, management, as well as requesting new certificates through a CSR. Then on the search service operations, the version 1 only has one endpoint, I believe, defined search service, which is where you post the query. But version 2, there is a global search where you ask your local MSR to query other MSRs, and then this endpoint here is where you would retrieve your results. So then, this is the get summary interface. This is version 1 of the SECOM specification. We will look at the differences between version 1 and 2, but as it's still in draft, it may change. As Ramin said, it is fairly stable, so shouldn't be. But yeah, this is version 1. The get summary just lists which data sets are available from the service you're querying. There are some filtering options. You have the container type, which is data set, which is just pure XML structure for the data. And then exchange set, which is zipped file, which is more suitable for Actis. The data product type you're looking for, so S124 navigational warnings, 125 ATON data. The data product version you're interested in. The geometry for the data, and we'll come on to this again later, but it's basically which area of data you're looking for. UN location codes, these are, again, we'll look at these later. They're 5-digit unique identifier codes for land-based areas. And then when the data is valid from, and some pagination. So this is version 1. Version 2, we see these envelopes that Ramin mentioned. This data moved into an envelope, and then you get the signature just to add to the security of the information posted. Next is the GET interface. GET it actually retrieves the actual information that you're looking for, rather than just a summary. GET summary. The filtering options are very similar to the previous one, except you also have this data reference here. So if you've done GET summary, that will give you a data reference. You can then just request that data directly instead of having to do a query again. And again, with version 2, we see this envelope and the signature generated to add to the validation of the request. So if you want to receive information, they are the most immediate ways, but you can also subscribe to data. So subscription allows the user to request a notification if the information changes on the data set. Has similar filtering to GET and GET summary. When data changes, the service will upload the data directly to the consumer, and updates to the subscription status will be made available through the notification interface. This is this is a post operation to the subscription interface. To create a new subscription, you can give a time frame that you'd like to subscribe to, and then when you're done, you do a delete request to the same interface to remove your subscription. So the upload interface, if you've subscribed to some data, a data set, when it changes, the server producer will try to upload that data directly via the upload interface on the client. This in version 1 already has the envelope structure that we see in version 2 quite a lot. So the envelope just makes it simpler to generate a signature for the data that's being transmitted. The envelope contains all the data to do with the signing. There is a size limit of 350K for base 64 encoded data on the upload interface. Just again, because of the poorer comms on the ships. Anything over that, and you would then have to use upload link and get by link. So the idea here is that the data producer tells the consumer where they can go to get that data and that it is available. They also get given a size of the data and how long they have to retrieve it before the link is stale. Then when the consumer receives this, they can get the data from the service's get by link interface, just passing in the transaction ID, which is just under there. Again, in version 2, the upload link interface hasn't really changed, but the get by link, we see this signature. Another interface, very simple one. This is the ping interface, which is just there to test that a service is healthy. In version 1, the response is this last private interaction time with the date time that you sent the request. It's used by the service registry to check the health of a service, check that it's still responding. Version 2 is not changed particularly. The name of the field has changed. Other than that, yeah, it's still the same. Another one of the operation interfaces is the capability interface. This is used to identify the supported functions of a service. So all of these correspond to endpoints in the API, and the service just lists which of these endpoints have been implemented on this service. This is very handy for obviously automating. If you know you can't, the consumer, the producer hasn't enabled the subscription interface, you know not to bother trying to subscribe and get that error message come back. In version 2, it's very much unchanged. There is an additional interface public key, which is just used to share public keys. But other than that, I think it looks very, very similar. Okay. So there's some important data structures to be aware of when using Seacom. The date time format in version 1, we've followed this S100 format, but that's now changed in version 2 to the ISO standard format, which brings it in line with everything else. We then have exchange metadata. This is used when you receive the data from the producer. This describes how it's protected, how the data can be decoded into something usable. Is it encrypted? What protection scheme is used? what signature algorithm, elliptic curve algorithm, etc., was used to protect it. The digital signature of the data, so you can check that it hasn't been tampered with. The public certificate of the private key that was used to sign the data, and if it's been compressed. Most of the data references are UIDs. These are fairly standard ID system. So a randomly generated unique universal ID is very unlikely to be duplicated. There is perhaps some need to map these to MRNs. Ramin mentioned that as well. But UIDs are assumed to be unique and service specific. Some of the other parts of the geometry we mentioned in the get summary interfaces, so you can use to query. They are human readable representations for spatial objects like points, and you can use points, lines, polygons. They're URL safe encoding, and you can see this if you were to query our ATON service without a geometry, you'd get 3 sets of data. If you then said, this is my route, and added that to the query, you would then just get the 2 responses, one of the English set and one of the Scottish set, because they're the only 2 you need. You're not going via Ireland. And it just helps to restrict the amount of data you're getting to what you actually need. There is some mention of GeoJSON, which I believe is better for web clients and easier to parse. But it's not really a priority to change this at the moment. So I think the geometry, the well-known text visualization is probably going to stay. The UN low codes were also in the data queries. The United Nations Code for Trade and Transport Locations, maintained by UNECE. Not all locations have been assigned geometries, and they're largely land-based, so of limited use, I think, in CCOM. So yes, again, as Robin also said, it all looks very complicated, and it does look like there's a lot to it, but a lot of the things that are done are kind of repeated. You know, we see this envelope structure everywhere, and then generating the signatures from the envelope everywhere. If you implement that methodology once, you can then reuse it. So it's not quite as complicated as it appears. You can reuse a lot of components and structures over and over again. Security is the same everywhere. And it's ideal for reusable libraries, which brings us on to the CCOM-lib library, which GRAD have produced and make available. So the CCOM-lib Java library, you get full functionality of CCOM right out of the box. It has direct integration with Spring Boot applications. It has support for version 1 and version 2 of CCOM. Our version 2 is currently based on the draft standard from about a year ago. So it does need to be updated. I think back then, a lot of the interfaces hadn't got this envelope yet. A lot of the data structure hadn't got the envelope yet. So we will work on updating that and get that done reasonably soon. You can run both versions simultaneously. You can import both libraries and then implement the different interfaces if you want to do version 1 and version 2. The functionality has all the security, packaging, exceptions, and logging in operations. So we have an interface for each, so a Java interface for each API interface. When you implement the Java interface, there's a default handler for exceptions and logging and functions that deal with this security and certificates. And this is if you want to use the library as it is, it's in a Maven repository. So if you just add our repositories to your Maven POM file, then CCOM Spring Boot 3 would be the version 1, sorry, of the CCOM library, and that version at the moment is 0053 snapshot. And then version 2 has this v2 here, and that's 003 snapshot at the moment. But again, as I say, that needs some work doing to it. If you would prefer, the CCOM library is public on GitHub. You can take a fork of the library and play about, to whatever you want. It's not a problem. We have the master branch is version 1, and then there's a v2 branch, which has the version 2 interfaces all defined in there. Okay. So the last section of the presentation, we're going to just have a brief discussion on the XML binding repository that we've been working on. This is so CCOM is primarily intended for S100 Exchange. It has an embedded data product type attribute, which you can then use to get the XML schema descriptions and pass the data out and turn it into objects automatically without having to write lots of code. The binding repo is here. That is available on GitHub. So hopefully we're going to have multiple language supported. This is the NIPWG XML binding repo. So we have the XML schema documents come from staging s100dev.net, and they're picked up automatically. But they are the IHO schemas only. So there are some that are missing, like S125, S201. So they are in the repo, and others can be added if need be. We have this Java library and a Python library at the moment, but I'd like to add more if they're needed. So this is the IHO GitHub location. Go and have a look. Yeah, that's everything. Any questions?
And if you don't want to raise a question verbally here, then may I suggest that you can also write a question in the chat, and then we'll try to keep an eye on the chat and answer any questions there.
Okay.
All right. Thank you very much, Lawrence.
Thank you.
And yeah, raise your digital hand or write something in the chat if you have questions. And now we're going from the generic presentations about SECOM and into the specific services that has been that we have been working with you with. And the next presentation will be by Julius Müller. Over to you, Julius.
Yeah, thank you very much, Thomas. Let's see how we can put what we just heard into practice and use our knowledge to implement a SECOM service. Just going to share my screen. Okay. So for those of you who don't know me, my name is Julius Möller. I'm currently the Senior Advisor Digitalization and Communications at the Australian Maritime Safety Authority. And before I start, I just shared a link and some credentials in the chat that will give you access to our demonstrator, the one that I will also talk about in this presentation. So feel free to play around and try to follow what I explain here on the slides, or simply just copy the credentials and have a look at the demonstrator later. So to begin with, a quick overview of what you need to understand on a technical level to implement a S124 SECOM service. So the specific product that we will be looking at in this example is S124, which is the product specification for navigational warnings. And this is obviously from the perspective of a service provider. So in an organization like AMSA looking to provide navigational warnings as a real-time service with SECOM. So first of all, you need to somehow produce the data sets containing the navigational warning information. And to do that, you should use a standardized format and encoding for that. And in the case of navigational warnings, we need the S124 product specification, which defines not only the encoding, but also the data model. And then as a specific implementation detail for S100 datasets to be used in ACTIS, you also need to implement and provide the dataset in an exchange set. I will explain that later in detail, but that is defined how to do that in the S100 base standard. Now, the idea is then, if you have that, to implement an API that can be used to talk to the service. We already heard a lot about SECOM, so I'm not going to explain that again. But we also need to know the specifics here for the navigational warning service. So which of the parameters that Lawrence just talked about do we need to implement? Do we need to support subscriptions? And all of these questions are defined in what we call the navigational warnings technical service specification. We also heard about SECOM using TLS for authentication and X509 certificates and all of that cryptography. And to do that, we need a public key infrastructure. For this, we will use the Maritime Connectivity Platform, and the Maritime Connectivity Platform has multiple components, and the one that provides PKI is the Maritime Identity Registry. And then finally, if you remember one of the first slides of Ramin's presentation, We also had a little box there that said service registry. So we also need something that can provide service discovery functionalities. We will also use the Maritime Connectivity Platform for that, specifically the Maritime Service Registry. Okay, so let's start with the S124 schema. So lots of the S100 vector products use GML as an encoding, which is an XML dialect. If you go to the website linked here on this slide, you can find the official S124 XSD schema as released by the International Hydrographic Organization. There is a project team actively working on the S124 product specification. So I would recommend not to hard code any XML processing, but to dynamically generate your model from this XSD schema. So we chose Java for our demonstrator for the implementation, but of course there are many different libraries available for different programming languages that can do the same thing and generate some code from an XSD schema. Just to mention it, the generation in Java is not completely straightforward, so I reckon it would be the same with other languages as well, but we had to use some custom programming logic to correctly transform the XSD to Java classes that we could use in our implementation. Of course, you also need to have a data source. In our case, we used an AI-based approach to generate the structured XML-based S124 data from text-based navigational warnings in the old S53 format. That is provided through our public website. However, depending on your existing systems, if you're looking into navigational warnings, you may already have some GIS-based representations of your data, and then you just have to transform that representation to the S124 GML. This is where it gets very technical, so I'm not going to spend a lot of time on this. Here are just two code snippets. On the left-hand side, you can see the script we use to generate code from the XSD. In this case, we use a library called JAXB as a schema compiler tool, and then some custom bindings in an XJB file to align the generated code with the rest of our implementation. On the right-hand side, you can then see how we use that generated code to put together an object representation of the warning and fill in all of the attributes to then be able to automatically generate XML from that. Okay, so that's how we generate the S124 dataset. And just as a note here, I would recommend that you work with the S124 product specification provided by IHO. It's just a PDF alongside the schema that you have to use to implement 124, because the product specification defines all the relevant attributes and data models. You should always make sure that your data complies with the product specification if you want to avoid any complications when loading the dataset on Actis. I mentioned earlier that you also need to wrap your S124 dataset in an exchange set, which contains a number of digital signatures and some metadata that is required to load the S124 dataset on Actis. An exchange set is basically just a standardized folder structure, as you can see here on the right-hand side, and this is defined in S100 part 17. And it is not completely trivial to implement. So a valid exchange set requires the inclusion of a catalog XML file, which is a whole different data model that contains the metadata for your data sets. For example, the geographical extent, the producing agency, and the digital signatures. You then need to think about how you want to provide your S124 as exchange sets, because an exchange set can contain multiple S100 data sets. So currently what we do in Australia is we provide 3 exchange sets for our S124 CCOM service. One of them contains nav area warnings, the other one contains coastal warnings, and the last one contains sea safety messages. Okay, so we're done with the first step. We have created our data set and the exchange set. Now the next step is to implement the CCOM API. If you start to look at the documentation for the S124 service, and I mentioned the technical service specification there, what you will find is a service specification document and a technical design document. You can and you probably should have a look at the service specification document for some general background information. But if you want to implement a service, you should focus on the technical design when you get into the programming, when you get into implementing CCOM, etc. So the CCOM technical design for the navigational warning service references the CCOM standard quite extensively. So you would probably also need a copy of the CCOM standard as a reference document. If you use Java for your implementation, as we did, I would recommend to have a look at the library provided by GRED, which makes your life a lot easier when implementing the CCOM interfaces, as we will see in a minute. So to implement the service, you have to implement a few components. Most importantly, the CCOM interfaces we heard about earlier. And on the right-hand side, you can find a list of the ones required for the S124 service. I think actually some of them are optional here, the subscription ones. I would have to check again. But if you want to implement the full functionality, these are the ones you need to implement. And then, of course, there's a lot of stuff around that you need to implement to comply with the encryption and PKI stuff, etc. But that's where you can rely on the library, for example. Then you also need to implement a few other things. One of them is the dataset management. So typically you will have to deal with multiple warnings, cancellations of those warnings. You probably need a few different indices on the data based on the query parameters that we saw. So you need to be able to query the S124 datasets based on the geographical extent, the UN location code, as well as the validity period, for example. But all of that is defined in the technical design. So if you have any questions on how to implement functionalities specifically, check the technical design. When you implement the subscription interfaces, you also need to have some mechanisms in your service to keep track of your subscribers. So you would need to manage a list, for example, of all the ships that have subscribed to your service and how you can contact them, how you can connect to their CCOM shore interfaces. And this also needs to listen to any changes in the data sets, because you always want your subscribers, obviously, to have the most recent data set. Then you need to implement some basic infrastructure, such as an HTTPS server that supports TLS authentication, which needs to integrate with your identity registry and the service registry, or in our case, with the Maritime Connectivity Platform. And one example for that is, for example, you need to implement certificate checks against the MCPs or the identity registry's certificate revocation list. So if you have someone trying to contact your service with their certificate, you need to check whether that certificate is still valid or if it's on the certificate revocation list. And then the technical design, as I mentioned, allows quite complex queries based on the geometry, the product version, and the validity period, which also, of course, need to be implemented and tested in your service. So this is a quick overview of the different packages in our implementation. We have the Java implementation of S124. So that's the code that we generate from the XSD schema. There are some database components to manage the different 124 data sets. We have some MCP services managing connectivity with the service and the identity registry. There are some processing utilities for geographical processing of datasets, etc. This is the subscription database, keeping track of all of the subscribers to the service, and also monitoring the actual database for updates. Most importantly, we have the SECOM interfaces. So for example, the GET interface, capabilities, subscription controller, etc. And then some additional classes for a WebSocket server that is used internally for manual dataset management. That's not really relevant for this presentation, just to be complete on all of the packages here. So this is an actual implementation of a SECOM GET interface based on the library provided by GRED. You can see the actual method here called GET summary with a list of the parameters, for example, the data product type, the geometry, and the product version. And then if you look at the bottom half of this code snippet, you can find some initial checks to see if the requested product is supported. And then we get into the processing to provide the requested data set. In this case, the last 3 lines refer to the provision of exchange sets. Okay, that's a lot of information, but let's just assume the basic infrastructure has been implemented. You have the 124 data set in an exchange set. You have the SECOM API. The next step is to do the MCP integration. So for the certificates, you will need to set up your HTTPS server that you use for the SECOM API to provide a certificate. That's very common. All of the HTTPS servers do that. And this can be any valid certificate that you would like to use. In our case, we decided to use an MCP issued certificate as it can be used to identify this service within the MCP ecosystem. But there might be other scenarios where you need to support devices without MCP capability, in which you can make use of basically any certificate provider, such as Let's Encrypt, for example. Now, the MCP identities and certificates are used to authenticate the communication between SECOM producers or SECOM services and consumers. However, I think Ramin mentioned it earlier, you also need to sign your payload, in this case, the S124 dataset itself. And if you look at a production service that provides S124 data that is Actus supported or compliant in such a way that it can be loaded on Actus, You cannot use an MCP certificate to sign that payload. You have to use an official IHO data producer certificate. To get that, you have to contact IHO and prove to them that you are a legitimate S124 dataset producer in your country. For SECOM, in our implementation, most of the signature generation and validation is handled by the Java library. You basically just have to load your P12 key store with the certificate and public and private key. And then what you should also implement, I mentioned that earlier, is a request to the MCP API or your identity registry to check the certificate revocation list for any queries you get from consumers with an identity to see if their certificate has been revoked. And obviously all of these keys are sensitive, so you need to secure them properly. On the right-hand side, you can see a summary of an MCP certificate, and one of the key properties of such a certificate in the MCP world is that it contains an MRN as the digital identifier for your digital identity. Now, the MCP's identity registry has a management interface that you can use to create and revoke certificates for your services. That's quite convenient, specific for testing. You can just see here a screenshot of some of the test certificates that we created through this interface. Okay, certificates are done. The last thing we need is service discovery. What is service discovery? Basically, it just means that you register your service in a public registry so everyone can see it. And of course, in general, that's always a good idea. However, in SECOM, specifically in SECOM version 1, as we heard earlier, it is also required to do that for the SECOM consumer. Why is that? A SECOM consumer is also an HTTPS server, as we heard earlier. And when this SECOM consumer subscribes to the service, so in our example, the S124 service, the producer, we need to know where to send the updates. So it needs to know, the producer service needs to know the endpoint of the SECOM consumer. So we can send an HTTPS post, for example, with the latest data set to that endpoint to the SECOM Shore interface. So what we've been doing when implementing SECOM is we have registered our clients in the service registry and then used the TLS client authentication of SECOM version 1 to identify the SECOM consumer, which would give us their MRN, the identifier that we just saw on the last slide in the certificate. And we could then use the MRN to do a lookup in the service registry to find the endpoint URI. Sounds complicated. You don't have to understand it on the first try. It took me some time to understand that as well. And as mentioned, SECOM version 2 will provide an easier solution. But if you want to have that compatibility for version 1, you need to implement it in the way that I just described. So here you can see the two different cases to get the endpoint URI of a SECOM consumer. The first case here is only supported by a SECOM version 2. We can directly get the callback endpoint from the subscription request. And then if that doesn't work, we have to resolve the MRN of that consumer via the service registry, which would then return the endpoint URI. And as soon as this is done in this code snippet, we can send them the latest update, the latest S124 dataset via the SECOM upload interface. Okay, last part of the presentation, we talked a lot about the SECOM producer. So the producer side, for example, the Australian Maritime Safety Authority providing S124 datasets via SECOM. But of course, on the other end, we also need to implement the consumer. Now, the consumer, based on my experience with S124, is less complex to implement, and the steps that we saw to implement the producer, the SECOM service, are similar. But again, as I said, probably a little bit less complex because you don't need all of that data set management and subscription management, etc. But yeah, I just want to show this quick overview here. So our consumer is called NavUI. That's the prototype link that I just shared in the chat. It has front end and a back end, and the back end actually implements the SECOM client interfaces and then uses the Maritime Service Registry in this case and its MCP identity to find all the available services, and among them, obviously also the Australian S124 prototype service marked here in red. And then it can automatically connect to all of these services and pull the required data. For NavUI, the list of services will be updated periodically, meaning if everyone implements a new service that is compliant to all of the specifications and registers it at the Maritime Service Registry, NavUI will automatically find that service, try to connect to it and pull all data available, and then make it available to the user via the front end. And that's basically the idea how an Actis would also work. It would automatically do the heavy lifting and then just display the relevant data to the end user. And then finally, I just wanted to show you how an entry in the MSR looks like. Most importantly, we have the geographical coverage area, the type of the data provided, and also I mentioned that earlier when I talked about doing lookups in the service registry, we have the endpoint that we can talk to using SECOM. And obviously it also contains the MRN that you can also find in the certificate of the service. And with that, we have successfully implemented our S124 service. So this is a summary of the technical architecture split into multiple components. First of all, we have the S124 producer, which uses our website as a data source, providing the text-based navigational warnings. We then use the OpenAI API to convert them into structured data to generate the S124 and the S100 exchange set, which is then sent to the SECOM producer. And we also have a UI here that we use to validate this AI-generated output. As we all know, AI is not 100% accurate, so there needs to be another validation step before we can publish the data. And this would be done by one of our operators in our Rescue Coordination Center, which is being operated 24/7, 365 days a year. So we can do all of that basically in real time. And then we have the SECOM consumer, which is the NavUI backend, which pulls data from all available services, including the Australian one, and then finally the NavUI front end. And yeah, again, if anyone has any questions, happy to talk about all of that. And I think Thomas in the end will also let you know how you can actually participate in these trials and demonstrations.
Certainly. Yeah, thank you very much, Julius. And it seems that it's not a very eager group to ask questions here. But yeah, again, please do, if you have anything, raise hand, write in the chat. But otherwise, we will continue in the program. And now we have a little hiccup here because we do, at least here in Europe, have a bit of a flu epidemic here, and that has struck one of our participant here, presenters, Pierre de Flong, who was supposed to have the next presentation. Ramin promised to step in here. It will be a little bit scaled down because Pierre was planning to make some demonstrations as well. But that we'll have to do without this time. But the plan here is to speak about a little bit more complex services than the navigational warning service that Julius was talking about. So, Ramin?
Thank you. Yeah, like Thomas mentioned, this will be unfortunately a very slimmed down and a demo with PowerPoint. So at least hopefully we will avoid any kind of demo effects. But what Per was going to demonstrate was basically a very, very simple use case of sharing a route from a ship to a VTS center and getting back a recommended route with a slight change from the VTS. Per's planned demonstration would have specifically concentrated around, yes, the APIs being used, but also then looking at the code in which, for example, the signature validations are done. First, of course, how the signature is generated for the envelope, and then how the signature is validated and all of that, which unfortunately I won't be able to show you at this point of time. But basically what we have is that the ship will send a route that is planned to the VTS, and the VTS will send back a recommended route with a slight change. What this looks like as GML, these probably look fairly small, and this is not according to S421 version 1, but the version 2 that is being worked on currently. But this is basically it. And one of the reasons why the date representation was specifically changed in the upcoming CCOM version to the ISO 8601 extended format was because then it is also compatible with the datetime format that is natively supported by XML. But if we then go deeper into what this actually looks like, this is a sequence diagram from the route exchange service design published by Ayala, and that is specifically written from a VTS perspective of what we have going on. Here you can see that the ship system is directly doing an upload to the route exchange service. It could do it via the ship CCOM interface. As you can also see that this term is somewhat different than I used in the earlier presentation. This is because these terms have been trying to find their correct format, and now Shore CCOM interface is what the IEC working group is settling on to describe the shore interface of the ship, because the ship CCOM interface is somewhat confusing on, is it on board the ship or is it on the shore or where is it? But what is happening here is that we have a mariner who does something to plan a route. They complete the plan. On the ship systems, there's of course a cross-check of the route or checking the route. And then what you want to do is upload the route. Based on the current draft, how this would, of course, work is you would have the ship system. If we follow the approach specifically in the current draft of the SECOM standard, the ship system would generate the root file, the GML file, and then it would also generate a metadata file for the 460 gateway, which tells the 460 gateway where to upload the root and what to do, and also what to do with it to specifically upload the root instead of fetch, for example, a reference root. But all that would happen in the ship systems. What we see from a SECOM perspective is that the root exchange service receives an upload with a root file. There, of course, you should validate the root structure. In the case of the root exchange service, we've specified that it has to, of course, be conformant to the XML schema, but there are also several other business rules that validate the root so that it is a valid root from the VTS perspective. Then you have some kind of method in the background to send the root to the VTS system itself. If the root exchange service is a component of the VTS system, it's probably just store it somewhere or something like that. At the same time, again, a part of this closed loop communication is that the root exchange service, once it knows that the end system has that root, it will acknowledge that it received the root. There are some issues with this diagram that will be updated. Here, this would not be the root ID, but specifically the transaction ID of the upload. And then we're also replying with 1, which means that this is a delivery acknowledgement. If the ship system desires it, and so far it is being specified that yes, it does, especially in root exchange, then the Shore SECOM interface will pass this acknowledgement, of course, then to the ship. The vendor API is in here. We don't know exactly how this happens. It could be a pull from the ship, or it could be a push from the Shore SECOM interface. What also needs to happen is that the ship systems need to, especially in the root exchange perspective, subscribe to the root exchange service so that we have a return pipeline. And I'll go back into that. But basically what this means is that the ship systems instruct the Shore SECOM interface to create a subscription for this root. The subscription is then created, or a subscribe request is sent from the Shore SECOM interface to the root exchange service, which then returns back with a subscription ID. And also to establish the other way of getting updates, the root exchange service will also subscribe to the vessel to get updates to when the route changes. There has been some discussion, is this absolutely necessary? Some VTSs have defined that they are only interested if the route changes in their area of interest. Some VTSs have stated that they are interested if the route changes at all. So that's why there's this geometry possible here. So a VTS can say that I'm interested in only changes in this area, if the route changes in this area. And then, of course, there's another subscription ID returned back toward the root exchange service. The reason why we have specifically this first subscription happening is that now when the subscription is used to create a pipeline between the Shore SECOM interface and the root exchange service, now because the Shore SECOM interface has an open HTTP port, using this subscription ID, they can filter out that only valid subscriptions are passed on to the vessel. Otherwise, there's the problem that if you have an open interface on the shore and you receive a random route from somewhere, if we have no way to open this pipeline, then basically you would have to send all of these routes that you receive, even if they're spam routes, back to the ship at some point of time, and the mariner would be spammed. So this way, the ship systems and the shore SEACOM interface can control directly with that who are we going to communicate with, and received routes from who are we actually going to send to the ship. And that's also one of the reasons why the recommendation is to avoid listing the ship or the shore SEACOM interfaces in a service registry. Because again, it opens up the question of if the shore SEACOM interface receives something, when does it need to deliver it to the ship and make it available to the mariner, and when not? But then once this is done, now we have the acknowledgement delivered that it's been delivered. I mean, the delivered acknowledgement has been delivered all the way back to the ship system. Now, of course, what we need to do is once the VTS personnel opens the route in the VTS system, then we need to trigger a second level of acknowledgements. So basically then we have again, the route exchange service sends back an acknowledgement with the information that it was opened, and then that is delivered to the ship system as well. Anyone who's used WhatsApp or Signal or any of these modern chat systems knows that basically there's the first check mark, which is pretty much the technical acknowledgement that the route exchange service received it, the technical HTTP ACK. There's the second check mark, which is it was delivered to the recipient's phone, which is this acknowledgement here. And then there's the fact when the check marks in WhatsApp's case change to blue, in Signal's case they change color also. And that's when it has been opened, and that's the second acknowledgement. So now we've achieved the closed loop on this side. Then, of course, the other part is then that we have the VTS open the route, they create a recommended route, the VTS system delivers that to the route exchange service, where again the route structure is validated. Now then, an upload is done to the shore SEACOM interface. Shore SEACOM interface delivers the route to the ship systems. When it is received by the ship systems, then an acknowledgement is sent back that it was delivered. And then, of course, once the mariner actually opens the route, then a second acknowledgement is sent back to indicate that it has been opened as well. In simplicity, this is what it looks like in a more complex interface. It would have been great if PAD would have been available to actually demonstrate this in code, and specifically in code show how the signature verifications and all of those are done, because that would be, in a way, more interesting than just looking at a sequence diagram. But again, I'll hand it over to Thomas if there aren't any questions.
All right. Thank you very much, Ramin. And I will just make a very brief presentation in the end about the digital incubator, or the open digital incubator as the formal name is. This seminar is now more or less an official IALA seminar, but it spins out of the digital incubator work that has been going on for a couple of years now. The purpose and the scope of the digital incubator is to, as Minch also mentioned in the beginning, is to implement the technical e-navigation services that are now being specified by IALA and IHO, and hopefully in the future other organizations like maybe the World Meteorological Organizations, other relevant organizations, and as these technical services are now based on MCP and SECOM. So it's a collaboration about implementing these services and collaborating on that. And then we are trying to lower the barrier for such implementation. You heard about now the SECOM library that has been developed and the language binding repositories. So these are things that are made to lower the barrier for such implementation. And this seminar is another thing that that we have made the initiative to undertake to help others in starting to implement these services. And the other thing is that we are providing feedback to the standards, of course, to the technical service specifications themselves, and this is not done very formally usually. Usually it's just the same people that are attending the different organizations where this is happening, but in practice we are delivering feedback both to the technical service specifications themselves, but also to the core technologies being used. When we have been developing these services, we have been providing feedback to both the SECOM specification and the MCP, and also to S100 itself, and this different S100 product specifications. So this is the purpose and the scope of the digital incubator. We have a lot of organizations. The mailing list is actually very long with many different organizations on it, but there are a few that are very active. It's always like that in these international collaborations. But we've been working on, of course, the navigational warnings. We've been working on technical service for ATON provision, traffic clearance, route exchange, marine protected areas, and we'll continue to do that. Of course, one thing is that we have several organizations implementing the same services, so we can test the interoperability of the implementations, which is another important aspect here. We will focus in the near future. The plan is to focus much on route exchange. That is, of course, very important, being mandated by IMO. So we will be implementing that and testing that, but also taking in other technical services. It is really whoever is joining and have an interest in particular technical services, we can bring that into the portfolio that we're working on. So we have the web page. You probably found the information about the seminar on the web page, digitalmaritimeConnectivity.net. Anybody that wishes to join they can find my email address basically on the web page. Drop me a mail. You get on the mailing list. And the way we work is that we usually meet bi-weekly and discuss the progress and the different technical services, and go into details about these implementations. And yeah, that's how the work is being done. So everybody is welcome to join. And now we have actually concluded the program. We will repeat this seminar Thursday. It will be at a later time, and the idea, of course, is to make this accessible for people in different time zones. So it will start at 1600 UTC on Thursday. The plan is to go through the same program, but hopefully we will have there. So we'll have that a full presentation. And again, because of the time zone, then presentation on navigational warning will be done by Martin from Canadian Coast Guard rather than Julius, because we don't want to see how Julius looks in the middle of the night. So that's the plan. And for if Pierre's not there, then I hope we can rely on you as a backup again, Ramin.
Yes, you can.
There, we did have some interactivity in the seminar after all. And now we are stopping a little bit ahead of time. We didn't have any registration for this. We have no means of getting any feedback. We would like that. So now I'm going to try to ask everybody here, in particular those that are not part of the digital incubator and have been presenting here, everybody to write something in the chat, a tiny little bit of feedback for what we have been presenting today. You can write a number, 1 to 10. 10, it was brilliant, the best seminar ever to have seen the light of Earth, and 1, it was terrible. But more valuable will be a little sentence about maybe something that you missed, something that you would like to have more detailed information about, some topics that you would like us to cover. So please write a little something that would be very valuable. We won't have time to adapt much for the seminar on Thursday, but as we also, this is the second time around, we did this in the autumn as well. We may be doing it again in the future. So if we could have any feedback, that would be very, very much appreciated. So I'll keep this session running a little while to allow you to write something, even if you want to write in your native language. We'll figure out to translate. That's very easy these days. And the seminar will be repeated, but maybe with a little different content on Thursday. So please write something, and maybe I'll see some of you Thursday, but it is intended to just be a repetition of this. Thank you very much. Checking out.